Hey everyone, this is the Kubeflow trainer and Katib call on 18th of February. As always, we're going to record this call and we're going to publish on YouTube, and we follow the CNCF code of conduct. So just before we get started, like any new people here on the call who just want to say hello, want to introduce yourself, feel free to use chat or like unmute yourself if you want to say hi. Otherwise, we'll get started.
Yeah. Hi, I'm
Hi.
Sakshi. I'm new to the community. Yeah. Hi, everyone.
It's great. Thanks for joining. Thanks for joining. Anyone else want to say hi?
Hello. Hi. My name is Vasilis. Um, I'm also fairly new to this community, hoping to make some progress with you.
It's great. Thanks for joining. Appreciate the time, Mr. All right. So, anyone else, or we can move on? Um, all right. So I guess we have a few topics today to talk about. Maybe first of all, we just want to give a update around the release. So again, like as I mentioned before, we're planning to release to the two before KubeCon. So my hope is to have at least RC by March 1st, which means like we need to do a lot of work as soon as we can because there are several ongoing work streams going on. I think most importantly, we should talk about template overrides, and I hope we can spend, like maybe some time on the day on the call to, resolve all the breaking changes. But in addition to that, like we already made great progress. Like the JAX has been merged PR. Also, we merged some things for pod template override and XGBoost cap. So I know that we right now have an open cap for XGBoost implementation, which I recently added a few comments here. So I hope we can make this before release. So definitely, like if you want to help, this is the great place, for you to actually understand the project and get engaged. So please help us with the review. Yeah, so this is the PR. We definitely need to get review. Also, like in addition to XGBoost, we do have what is it? The one second. So the Flux implementation PR, which also going on right now, and this is in progress. So we need to merge this review actually, this PR. I think we already have several comments here, but if you get a chance to help us, please help us with the review for this Flux support to the trainer. And what else? Like TTLs. Um, so for TTLs, I think we need to finalize a design. I think we have an open cap, but I think it's almost there. And I think implementation also ready. So it looks like we just need to get the final approval from maybe you, Antonio, like if you have time to at least take a look and so we can move on for details into the two. Um, yes. And yeah, the Tensor caching is, I need to speak with Akshay around this. But anything else, I think we're good to go. Anything else? Any urgent tasks we need to work on and prioritize the work before to do two?
I think we do have that release generation. I think Melinda was working on, but that I think he deferred to someone else. And do you need it urgently? I think for me it will be much easier. I can just copy paste what we have in SDK.
Yeah, I think definitely. So, Akash, would you be able to actually prioritize this work for like take over the PR and just finalize the work?
Yeah, sure, sure. That's what I want to confirm. I think.
Yeah, I think that will be super helpful if you can do this because then we can release much faster because that will, just reduce a lot of process on our side. Um, and you haven't opened it yet, right? The PR.
Sorry.
You haven't reopened the PR. So first of all, let me ask you, can you directly push to the millionth branch or you need to have a new
No,
PR?
I don't think that's his work. I don't think I
Okay.
can push to his work. I think
All
better
right.
since we do have a working version for SDK, I'll probably replicate that. I think one more contributor are looking to contribute. I'll see if he or she
Yep.
want to help with that. That will be super helpful.
Yep, absolutely.
Yeah.
Yeah, definitely let us know, like, if we can have this before release.
Yeah, that's why I asked for whether we can have this before or not.
Yeah, makes sense. Anything else? Yeah, I think there are, I mean, first of all, this is, I think, one of the largest release for us because we do have a lot of new features. And I think it will be several breaking changes we also need to reiterate once we have a release. Like, first of all, we introduce immutability to change op API. And I think we need to also talk right now about immutability of training runtime API. So this is something we also need to consider to push before release, because we want to push breaking changes as much as we can before we actually, graduate our API or do other things. So this is important. Um, all right. So immutability, I think I will. Yeah, this is the breaking change we recently introduced to train job API to like actually not allow users to modify some of the parameters which are immutable on the job set spec. So this is also important. Yep. All right, sounds good. Anything else for this release? All right, so we can move on. So for the next topic around deprecation, so I think we have some discussion in Slack. I don't know if you've been following, but like we probably want to deprecate non-proc per nodes API, at least on a Torch ML policy. So the reason why I would introduce API in the first place, like we're thinking about like users might want to have more control how many GPUs available on a single node, and non-proc per node usually represents how many devices are available in the single pod. So imagine you have like multiple pods which you present as a node, and inside every pod you might have like 4 GPUs, and this parameter actually defines this value. But I think what we found out, like usually this parameter can be automated by container resources. So my question is like, do we want to deprecate it before the release, at least on the Torch ML policy, and see how it goes? I think today, if we don't set this parameter, we automatically generate this based on the container resources. Any thoughts like from your side, Antonio? Maybe you have any feedback from customers or users like who've been using this in PyTorch job, or um, they don't really worry about this parameter at all?
No, no, we don't have any evidence that people are using that field.
Okay.
And it seems like mostly for what we do, it's always PyTorch at the moment. So generally defaulting to a sensible value, like as we discussed, like either the mean of GPUs or CPUs, or just default to one if there is no resource defined. That's probably something that would work for us. I haven't looked at the comment that Vanessa and Yuki mentioned about MPI. It seems like it's a bit more
Yep.
complex for those scenarios.
Yeah, I think my suggestion is on the 2.2 release those two APIs, non-proc per node and elastic policy from Torch, and keep it on train job for now, and also on MPI. Because if we remove it from train job, there will be no way really for users to override this for MPI use cases, right? So yeah, maybe we should. What do you think about it?
So if I understand it, you're proposing that we will remove them from the Torch ML policy, right?
Yeah.
But yeah, that makes sense. Yeah, you're right. Because where are are they? Is it redefined for the MPI policy or?
Yeah. So MPI policy
Okay.
also had the same parameter here,
Okay. I missed that.
and it's here. Yep.
All right. Yeah. And if I would say because we are still alpha, the API is still alpha. We can afford to make that at
Yep.
the worst case scenario. We just have to reintroduce it.
Yeah. I
But
think
that
it's
would yeah, that sounds
that
good.
makes sense. I think after 2.2 we should talk about the trainer API, the train job API. So because I think like once we merge the Flux PR, I kind of like that belongs to more HPC use cases, and we understand better like how these slots can be used within API context, right?
Yeah.
Because right now it's really kind of unclear for me how people use this number of slots for
Yeah.
like API jobs,
Yeah.
right?
Yeah, I have to admit it's a bit obscure to me as well. Yeah.
Okay. Yeah, so then I guess next step, remove from Torch policy, keep it here for now, and keep it an API policy as well, so we can iterate. All right. Any other feedback on this from other folks, or I think it's relatively straightforward?
I'm just a little bit curious. Is there gonna be like a base field inside the training runtime? Is it just gonna be for MPI?
Mhm.
Okay.
What do you mean by base field?
So actually correct me if I'm wrong, but the way I understand training runtimes is that you have your either cluster training runtime resource or
Yep.
the namespaced one, and then your train job references one of them and says, I'd like to use this specific training runtime. And
Yep.
then when the actual jobs get created, there's like a merging strategy which
Yep.
combines the information from the training runtime and layers on top of it the actual things from the train job, and then you get your resulting object. So then my question is, where exactly is the torch policy you were suggesting you remove the
Yeah.
num-proc per node? Is it
Yeah,
in the
yeah, yeah.
train
So
job?
yeah, that makes sense. So yeah, so you're right. Basically, the idea of runtime is kind of reusable templates, where kind of like we have more detailed parameters that platform usually admins can provide, and trade job provides a minimum set of knobs, usually kind of required for scientists or for like for batch submission to trigger those jobs. And so basically, today, non-proc per node it defines in the torch policy. So if we go to one of the runtimes, and this is just example of runtimes. We do serve this, we do maintain them in the community, but this is not, and this is not mandatory for people who build on top of Trainer to use. Like for example, we have customers who build their own runtimes and they don't use the upstream runtimes. But if they want to use this as a reference, they can always see how, what is the way to manage them. And here, basically, like right now in the default torch, we provide non-proc per node parameter, but you can override it. And this will be like a default value that will be used across all the jobs unless they modify it. Because train job API also has the non-proc per node API field. Um, yeah, so if I go to, yeah.
Exactly. That was my
Mhm.
question, because then you're suggesting you leave it for the MPI policy, but you
Yeah.
remove it from the torch. And I didn't understand the reason why it's not good enough for torch. Is it because people
Yes.
don't rarely use it? Like they
Yeah,
set to the auto value?
exactly. So for Torch, what we
Okay.
found out, like people just omit it, like keep it empty. They don't really use it. They only use like number of nodes and resources per node. And for Torch, they just, submit the jobs without worrying about this value. This is what we found out. So basically for Torch-based jobs, this value will be empty for now.
I understand.
That
So
makes sense?
so you would like to reduce the surface of the object that okay,
Yeah.
I understand. Okay.
Yeah, we would like to reduce the surface of Torch policy object on runtime. So which means like we want to remove the unused APIs and introduce them when we see more use cases. Like because similar things we have with Elastic policy, for example. Like when we designed this trainer project a year ago, we want to support like Elastic PyTorch, and we kind of like introduce this Elastic policy API to actually be kind of aligned with V1 with PyTorch job. But I think what is the right way to do these things is actually not introduce API, but extend them in the future, right? When we see more use cases. Because today this elastic policy is just not, it's just a dummy value. We don't really use it at all. Um, yeah. So similar things we want to do with non-proc per node for now for TorchML policy. Yeah. All right. Any other questions? All right, so then move on to template overrides breaking change. So just to inform everyone, like we do have this mechanism like called pod template overrides, which actually let me quickly open it here. Um, so this is the yeah, pod template overrides. Um, So the rough idea is to allow users to override some values from job set template, because what we found out, like we do provide several like knobs in train job API to modify like number of nodes, resources per node, image, command, or other things, but we don't want to expand all of the values to train job trainer API. So the idea of pod template overrides, it will be on the train job side, but if you want to modify some values like volume claims or like service account, more kind of system, I would say, parameters, which data scientists usually don't really understand. They don't need to understand. we do provide this mechanism for, to actually override other values on the template. And the first use case was queue. Like in KQ, we use this API to inject node selectors and affinity rules. So when queue admit the train job, queue automatically configure the right value in the pod template override. But I think what we found out, like the initial API design was probably not ideal because um, we kind of like lose the ownership of the override. So this is the kind of like the example of how it can look like. So it has like the target job, it has the spec, and then the spec you define what kind of overrides you want to give to the job set. But I think again, like we found out that the ownership of this override is unclear, and we want to introduce a new parameter called like manager, which is responsible who control the override. And I think there are like I think we have this. The idea is defined here. So pod template, yeah, pod template override. I think this is the PR been merged like 2 days ago. But the idea of the manager, yeah, I don't know if we have any examples. Manager. Yeah, so I don't know if it's here, but we want to like introduce a new parameter called manager, which will be part of the pod template override API. And maybe I can open API so it'll be easier to understand directly here from Thomas PR. Yeah, so if I go to train job, pod template overrides. So this is an API, and inside API we have this new manager parameter, which is string. And the idea is like the queue will be injected some values, which tells that this override, like the queue is the owner of this override. Similar to this, like other managers, like, if you have your custom admission webhook or you have your custom controller, which do some injection, can also use this manager field to actually explain the ownership of this override. And what we found out, the API might look wrong right now because the manager, like we want to refactor this basically. And one of the ideas of refactoring was have something like this. Pod template. Yeah, we want to kind of replace pod template override with the template override, which allows actually in the future to extend this to also introduce overrides for not only for pod in the job set, but also for like job spec or job set spec or like maybe job metadata and other things. And the API might look as follows. Like we do have the template override API where I have a manager and every manager might own their own pod override or job override. Does make sense? Any questions so far? So I think it's a lot of information, but does it make sense to everyone, like what I'm talking about?
I understand the overall
Yeah.
idea, but I'm wondering about the details. Like, what can I change within the spec? Can I change the image, for example?
Yeah. Yeah, it's a good question. So not everything can be changed, and we deeply think about what parameters we want to introduce, like based on the use cases. Like for example, for image, if it is image of the trainer, we don't put it in an override because train job has a trainer field which already can, you can specify the image value. So image is more kind of tricky because usually image is something you provide once in the cluster training runtime, and then you can use the trainer API to to have a new image. Like for example, so if I go to trainer struct, we do have some of the parameters like image, commands, arcs, environment, like some basic parameters basically, which is like common for all of the job submission. But if we go to the details, like for example, pod security policies or volume claims, this is something that data scientists don't really understand or they don't need to understand.
Oh, I
But
see.
yeah,
So this is like Kubernetes native things,
yeah.
right?
So we
Like
kind of like
annotations. No.
yeah, the overall idea of trainer is to basically split the personas. Like we do have data scientists or AI practitioners who just focus on PyTorch and they don't need to understand Kubernetes at all. So we try to understand how to give them a simple API so they can, still see the value of our orchestration, but at the same time don't learn Kubernetes. They don't need to understand this is run on top of Kubernetes, right? Um, but at the same time, we provide additional flexibility for platform engineers to control like other parameters via this template override idea, right?
Okay, then this makes total sense because I think now this is gonna be like an array of templates. So you can
Yes,
have
exactly.
multiple managers changing multiple things, and each one is owning their own changes, right?
Yeah.
Okay,
Yeah,
I
and the more
understand.
interesting thing, it also will be mutable. So because like what Q does today, so Q suspend and preempt workloads. And when Q suspend a workload, it can also update the tolerations, right? Because it should place the workload on a specific rack or like do topology over scheduling. So we need to provide a way for those external managers to add more values to their list, right? This is why we want to introduce also time parameter to this field. Um, yeah. So I think it's definitely something, I think back to the discussion, like I know, like Vasilius, you have a controller who controls the job submission. This is something also we can talk to you later, how, those controllers can use this overrides to inject some values, for example, right, to make them mutable, if that makes sense. Because PyTorch job doesn't have this mechanism as of now. Yeah, so I guess my question is, so I know Yuki, he's not on the call right now, but I'm trying to understand if there are any limitations we have with this API, um, or in general, it looks good for everyone.
Well, Yuki raised the point about the design, whether we should go with one single field or two, as Yuki proposed. One advantage, so the API is still alpha, so we can break it, but it's no excuse to do. One advantage of Yuki's option would be that, as far as I can tell, it maintained backward compatibility. It would keep the existing field, right, and only add a new job template override field. So I'm saying that in the sense it's quite already quite used, but yeah, as I said, it's alpha, so that is okay. But if we have so that's one angle. The
Yep.
other to decide, I don't know, like I haven't very thought about it deeply, but it feels like it makes it a little bit clearer to have two separate fields, like because I don't know, technically those can overlap. No, what is going to be
Yeah.
or so there is the question of the overlap, but having two fields looks like it. I don't know. It feels a bit, but it's really an opinion.
Yep.
A little bit clearer.
Yeah, I
What
think
is
I
the
agree.
scope?
I mean, I agree. I think like, so the only problem I see with this approach. So first of all, I don't understand like why this is not going to work if we decide to break API in any case, because like I don't understand like we have a manager which can control both pod and job overrides, and the manager can also add more item to the slice if manager wants to add more pod overrides or more job overrides. So this is going to work fine. What I don't understand, why Yuki actually against it. Maybe we should talk about it offline. Um, yeah, because the problem with this API, it doesn't allow us to have a map where we have the key as the name, right? As the manager, sorry. Because this is
Uh,
actually not a map, right?
okay, but okay. So yeah, I missed that point. Yeah, there are multiple differences between the two proposals. The first one is that two fields, two
Yep.
first level fields, and then the
Yep.
other difference is the way manager are defined.
Yep.
Yeah, so
Oh,
so
yeah,
that
yeah, yeah.
that yeah, the first proposal breaks the manager field into name and time, while the other one is just the time is placed differently.
Mm. Mhm.
Yeah, so that yeah, you have to have a key, I guess.
Yeah, yeah. I don't
Uh,
know if do you know if you can have a key on a struct, or it's not something we can do in the. Mhm.
can have a key. No, you cannot. You cannot.
Mhm.
We've discussed that actually with Thomas, with the Q
Mhm.
folks.
Mhm.
Um, and Thomas tested it, I think, and it's not possible. You cannot.
Yeah, I think you're right. So yeah, this is the like the limitations we have, right? Because if we do have, I mean, this is actually, theoretically is a map. I mean, it's kind of like, a unique identifier for the
Yeah.
override, but we cannot define it, right, in the API.
Yes. Yeah.
That makes sense. Um, all right, so I mean, let's follow up for this again. Like, I don't see a big problems with this because we can have a map on the manager here, and also we can have a map on the time here, which means like we can, like we can have the um, in the future, right? If we want to introduce some mutability, it will be easier, I think, for us to manage, right? Um, because I think it's also for observability, if I understand it correctly, right? Like when we have this field, when I have the not the field selectors, but what is the API name in Kubernetes? Like basically when you do a apply patch, right? You can see the how the patch has been, has
Yeah.
been done, right? Yeah.
Yeah, and I think that key is that you can change. Each manager are gonna be able to patch only what they own, which is not
Hmm.
the case at the moment, I think, because it's
Hmm.
an atomic list.
Yeah, yeah.
For time, I'm not sure. Like, so you're saying time, it should also be a map. That's what you're saying
Yeah, I mean, theoretically, this list can be the map, right? If the time will be unique,
by
right?
time. Yeah.
Oh, it's might be tricky, right? Because yeah, because then like what will be the limits, right? What if you have like this like the same overrides on the same time, right? Yeah, on the same seconds, basically. I don't think it's a good idea to actually have a key as the time, right?
Yeah, that feels like that a bit suspicious, but
Yeah,
to build a yeah.
And
that makes
you also
sense.
have time zones. Like if you have nodes with different time zones, it also
Hmm.
becomes a problem.
Yeah, that's right. And not like the time zone, but like, we have seconds here. We don't have milliseconds. I mean, if we take because I remember like we talk about like we want to default the time to the system time when the time is omitted. This is something we will do on the server side if user actually, because so setting time in Kubernetes is very tricky, right?
Yeah.
And we want to, we want to have on the server side, which means the time will be
Yes.
the same, right? Yeah.
Yeah.
Hmm. Yeah, I don't think time is a good field for map. I agree. But I think it's fine to have this atomic list. Like, we can follow up, but I don't see any big deal if it is atomic list. So let, let's maybe follow up for this. At least we should agree on API. I mean, if we don't like the template overrides as the property, we can have, a separate pod template overrides and job template override and a reduce manager for both of them, right? So this also
Yes.
could be one of the options. Yeah.
Yeah.
Mhm. But like that basically will so Q if Q needs to do any changes, any mutation on the job metadata, it needs to do like both mutation basically on the pod template override and the job template override, right? Um, yeah, I can let me make a point here. So to that example, okay. All right. So just maybe like a quick question. So I think we'll also quickly discuss in Slack in the future where we want to introduce the overrides for runtime spec. So this is still unclear to me right now. It's because like what if in the future like user wants to override some workload API things, right, via the train job, like how we want to allow to do this. Um, Yeah, I think this is something we need to talk about. And the problem with the template override approach that might be blocked us if we want to use the runtime spec, right? Um, like because imagine in the future if you found out that we want to introduce the overrides to runtime spec, the template overrides might be confusing in terms of naming, right? Because it should be runtime spec override, something like this, right? Um,
Yeah. Yeah.
Yeah. Okay, that's fine. But I think like, the most important thing for us to agree something on before the release and maybe start to implement it. Maybe the Yuki approach, if we modify the manager a little bit safer because we don't have this, top level object like template overrides, but we can talk about it later, right?
Yeah, sounds good.
Okay. All right, so let's move on. Maybe just one small thing around this. Like I've also been thinking about if I want to introduce overrides to job set spec. The idea was to keep target job empty, but I don't know. So the question is like if you want to use this job template override in the future, not right now, but in the future, to allow override the job spec or job set spec. Like I don't know if that makes sense to actually use this API for such things. Yeah. We don't have it right now, but in the future, I would imagine maybe something which users might want, right? Yeah, right now we don't have metadata here. That's it. I think my idea was to, if we keep the target job empty, it applies to job set spec. If we specify the target job here, it applies to the job spec. I don't know if this is the best solution, but at least this gives us some, flexibility. But at the same time, it gives us downside if we support kind of other CRDs like growth or, like
Yeah.
Slurm, right?
Yeah.
Yeah. Um, okay. Do you any thoughts on this, or we can talk about it offline? Okay, that sounds good. So yeah, let's maybe jump to this. Yeah, I can probably move on. It's after this. Yeah, so dynamic trainers. So I think we've been talking a little bit about this with you, Vasilis, around the validation part for the cluster training runtime. Do you want to give a little bit of a context, like what you do today with PyTorch?
Would you like me to explain how this works, like what I was thinking of,
Yeah,
one use case?
yeah.
So basically, the idea that I'm exploring these days is starting from, let's say you have a cluster that's managed by maybe Q or maybe something else. And as a user, you're working on a shared cluster. So there's other people on this cluster. And GPUs are expensive resources, so you don't have infinite resources. What I've observed, because I'm using one of those clusters, is that people submit jobs and they ask for as many GPUs as they can get, which is not always the same as the number of GPUs they should be using or the number of GPUs they could be using if they were more like a polite and community driven, right?
Yep.
So what I was thinking is, what if a user submits their PyTorch job, and then there's an automated system running on this cluster which inspects the job and says, well, you shouldn't be using 64 GPUs, you can use 8 somehow with some intelligence. Let's imagine there's a black box somehow that can recommend the resources. So once that happens, and I have like a diagram here that involves Q, but effectively, thank you. The idea is you have your job, you submit it, and then if we imagine that Q is working here, the way Q works is it suspends your job because that's how it behaves. And what I would like to do is, while this job is suspended, I'd like to give a hint to Q to just don't schedule it. And we have a cap, which probably will make it into Q in version 17, or at least that's the working plan at the moment. So that's gonna introduce effectively a scheduling gate at the granularity of Q managed jobs. So in my PyTorch job, I will have an annotation and will say, this job is actually managed by a controller, so schedule the gating for this job. And there's like a dotted line here that leads to this bottom group of boxes. And what happens then is a controller kicks in, it inspects the PyTorch job, it looks at what the job is doing, and then it decides new resource requirements. So it will change the resource requirements of the PyTorch job. It might also change like the number of replicas. And because it changes things like the number of GPUs, it may also update the command line arguments. So this sounds a bit scary, but the idea is, because you can't apply it to every single universal application out there. This is why we're thinking of having this concept of plugins. It's this purple pink box. So developers can design these black boxes that can give you recommendations for resources. And then you just hook it with a simple Kubernetes controller that applies the recommendations to the object. So then you can have some sort of a catalog where you say, for example, if you're running tuning jobs, you can use this plugin. If you're running inference, inference jobs, you can use this plugin. If you're running HPC jobs with LAMPS or Gromax, use that other plugin. That's the idea, because you can't have a one-size-fits-all algorithm for this stuff. So after the controller has finished patching the job, then it just says, well, I'm going to remove the scheduling gate. So then Q can kick in and just schedule it the way it could always do. Now, this thing, and we have a prototype controller you can try out if you like. It works for PyTorch job. We didn't implement it for Kubernetes, for Kubeflow version 2 and train job. And because Q is missing one of those features I mentioned, this scheduling gate thing, we're using a workaround where basically we're creating a new object instead of modifying the existing one. So here in this comment that Andre is showing, I was asking, is this something you would like to see in train job? Because what I did is effectively treating train job as a black box, and I'm working with Q. If you think about it, this is an integration with the Q ecosystem. It doesn't really touch Kubeflow. So I was wondering, do you see a future where the resource requirements of train jobs are somehow automatically updated by controllers running alongside by other managers of sorts?
Yeah, definitely. Like I have a few thoughts on this. Rison, go first.
I was just wondering, how do you solve the problem with monitoring? Especially if you have GPUs that are shared between multiple workloads, it's difficult to keep track of, GPU utilization and memory utilization, for every GPU. And then you have different types of GPUs. For example, you can have 80 gigabytes for A100 or 24 gigabytes for different type of GPU. And essentially it becomes like real-time monitoring of resources is challenging problem, and essentially you need this information to make a decision how to schedule resources. I think this is also a problem that DRA, dynamic resource allocation, is trying to solve in Kubernetes.
That's a good question. The answer is I don't have to, which sounds weird, but the way I did this, let me take a step back. The correct answer is I would like to do this, but I think it's slightly difficult to get it perfect from the get-go. So instead of trying to boil the ocean, I started with something super, super simple. So in this flow you see here, the job hasn't started yet. I'm changing it before it even schedules on the cluster. So then if the question is, how does this autoconf plugin know how many GPUs my workload needs without my workload ever running? There's a long answer to that, which you can find if you go to the repository. But basically, we have a way where we generated models that understand a specific workload. And this workload is a tuning, it's like a tuning wrapper over the SFT trainer API in Transformers. So we've benchmarked 40,000 different configurations, and from that information we have a model, and with the model we built a recommender. So we just feed it with the details from a tuning job, and out the other end we get how many GPUs to use and how many nodes. I hope that answers your question.
And do you consider like different types of GPUs or?
Yes, we've tested Like on a heterogeneous cluster, we've tested different kinds of GPUs. But of course, there might be there might be a case where the specific model we build doesn't work for a specific version of hardware you have. Which is why we went with the plugin approach, because what that means is all you have to do is just train a new plugin for the things that you would like to use, or find a different recommender, right? Effectively,
Yeah,
I'm cheating. I'm
it-
making the problem a lot easier.
that's the problem. Yeah, makes sense. Andre?
Yeah, definitely that makes sense. So this model that you train, like, do you run them in your controller? Like this classification problem, right? Like, yeah, the model that you
I have
pre-train on, on a bunch of use cases.
Okay, good question. I have two modes in this controller that I built. One mode is exactly what you said. It's running alongside the controller. The other mode is because I would like to be able to update my experiments. So I call them experiments. I would like to update my model. So I have a way where there's like a REST API that's speaking the language of the recommender API. So it receives the job specification, and at the other end you get the recommender. So I can just go in the REST API and update the models without having to restart my controller or update it, if that makes sense.
Yeah. So, but the model, so how do you do prediction? Like, do you analyze, I guess, like you're analyzing the parameters, right? I mean, for SFT trainer, right? From my understanding, like the SFT, the wrapper you have on top of a SFT trainer, it gives user an option to provide, like, information about batch size, number of epochs, and other information. So you take this information,
Yeah.
yeah, you input this to the model, and your model give you the correct details around GPUs, right? The optimal details.
It is kind of like that. It's a little bit more involved. So
Okay.
I did not create the model. I created other things, like I
Okay.
did the benchmarking and stuff, but the model is effectively using a classifier. And all of this is open source. You can
Okay.
find yourself if you like. But imagine that it's like a classifier that says, is this job configuration feasible or not? And it tries a few different jobs, and then it picks the
Yep.
one that works the best.
Okay. Makes sense. Yeah, actually, you have hands up.
Yes, sorry. So my question is, if this is cause any confusion for the users when they check the objects via pixels or any kind? Or
Sorry,
should
I
be
think I can't hear you properly. I think there's something wrong with the microphone.
Yeah, actually can't hear you.
Sorry, can you hear me now?
Yeah.
Yeah. So my question is, I think I like the idea, but would it cause any confusion for the users who would actually check the resources like the train jobs by kubectl or any client when we dynamically update the params like number of GPUs? Should we, my question is, should we enable this for all the train jobs, or should we create a specific type saying that, okay, we'll ask users to allow like platform components to update the resources dynamically?
I'll tell you how I'll give you my perspective on it. So I agree that it could be disruptive to everyone, which is why this is a completely opt-in situation. When the user creates their job, they specifically add the thing that says, I'm opting in for this specific plugin to update my specification. So it's not like a far west situation, like it's very targeted. The job itself is requesting a specific plugin to update it.
Makes sense.
Yeah, I think yeah, so sorry. I think I definitely agree because again, like this definitely resonates with us as well because users sometimes they don't understand the difference between H100, GP200, how many GPUs they need for their jobs, and usually what they do, they run a bunch of tasks. They check utilization, which actually requires a lot of time from scientists to actually do the work, right, and train the model, and they try to see how they can optimize the neural network so it like consume as much capacity as they can. I agree that might feel confusing. Me as a data scientist requesting 5 GPUs, but you give me only two. But if my work will be done, this is something what I need. Like myself as a user, I don't really care about GPU, TPU, like what resources you use. I care about my neural network to be trained or fine-tuned, like as fast or as optimal as we can, right? So I can get my job done. Like which means resources, it's something which should be abstracted from the user perspective, right? Like that's why sometimes it's hard for scientists to predict and to understand how many GPUs they need, right? Um, so I totally on board with this solution, and I think this is something I hope we can integrate with train job controller as well, because I think we have all the knobs and require parameters to like to make it possible. Um, I think a couple of questions from my side. So the wrapper they built on top of SFT trainer, I think I asked this already in the thread, but you don't give a user an option to modify the script, right? So this is something more about configuration driven submission, right? Um,
Correct.
okay.
And actually, the way I do it, I think is suboptimal because
Mm.
I'm literally changing the command line. Some of the things are specified the command line, which means the controller has to parse the command line and find the right argument and change it, which sounds iffy, like it sounds unreliable.
Okay.
I'm imagining if this were a first class feature of train job or something, it doesn't matter,
Yep.
of a thing, I'm imagining there would be like a mechanism which would say, these are the things you can parameterize my job, and
Yep.
then this is how these things are reflected to my job.
Yep. Yeah. I mean, yeah, that makes sense. So again, like our idea was, I don't know if you've been exploring this documentation, but so we do have provide this idea of built-in trainers. An idea of built-in trainers, we kind of like because we have this idea of runtime, we can actually have a blueprint of fine-tuning of any models. And like I think initially what we try to do, we try to kind of use TorchTune. So TorchTune is a library on top of PyTorch, which actually provide a set of recipes, which can do, like SFT fine-tuning, LoRa fine-tuning, I think any type of different fine-tuning, and they do provide a set of recipes so users can reuse them, similar to Onslaught or like Llama Factory, like similar to these type of things. And like what we do initially, we kind of like provide a set of pre-built template configuration for multiple models. Like it could be Qwen, Llama, like Kimi, it doesn't matter which model, but like we provide them kind of initial template they can take and they can trigger the fine-tuning by just referencing this runtime. But if they want to adjust like some of these parameters, like for example, like let's say I want to adjust the batch size or like LoRa configuration, we give them some sort of Python API here where they can say, let me give you some examples quickly. So yeah, this one. So this is the like TorchTune config. They can adjust like batch size, number of epochs, loss, number of nodes. So they don't have a way here to configure the script, like the training loop, but they can adjust some input configuration that TorchTune allows to modify to trigger the fine tuning. And also they can like for example configure which data set they want to use, and then they reference to this runtime which has like other configurations which is required to orchestrate the fine tuning job, right? So I find the kind of similarities between what you do in SFT trainer and here, right? Because this is pure Python. This is not YAML. Like user interact with this API using just a Python client. So we can think on this how we can extend this right to support, like this intelligence submission based on those values that have been provided by the user, right? That does make sense?
It does, because while you were showing this, I was thinking, this is perfect. How do I access it from my Kubernetes object? I think this is
Yep.
the glue that we're missing, right? That's what you're
Yep.
proposing.
Exactly.
I think this makes total sense. And the other bit that I haven't worked out yet is, as a user, specifically for what Akshay was saying earlier, it's disruptive, a random guy going in and changing your resource requirements. How do you select the plugin you would like to use for your job? Is there some kind of a catalog we can come up with, some kind of a registry?
Yeah.
Like how do I pick my algorithm?
Yeah. So yeah, I mean, this is something we definitely should talk about later and more on this because we've been thinking about, users can list runtimes and like it can actually give them a way to, this runtime for like Llama 3.2 fine tuning. And it has some, like built-in trainers or like initial configuration they can see. And they can adjust the configuration by using this torch tune configuration that I showed to you previously. But we've never got a chance actually to think deeply. But if we combine this intelligence with the way how users, submitting a job, I think this is something we can also discuss. Because the glue will be, like they will still work with Python, right? Don't need to really interact with the YAML files, right? Yeah, this one. So I think this, yeah, and also like another idea, like we can also analyze the not only the input parameters but the entire script. So what I was thinking about, imagine you like because what you need to do, you need to basically take the user's PyTorch code, push it to the agent or push it to the model, and the model, like should give you an output of the optimal GPUs you should use to run the script, right? So theoretically, like imagine like you have a Claude, right? You have entire script. You just ask Claude like, like what is the best, like most optimal number of GPUs and what type of GPU I should use to run this script, right? And this theoretically should work. Like we just need to automate it in a way how users submit the code to the way when the job is submitted to the cluster. Yeah.
That would definitely be interesting. You know what might be useful? If we wrote like user stories, if we wrote, this is an example and I expect that A, B, and C will happen, and we have a couple of those, because I'm imagining if we do this exercise, we will find some emerging common principles, right?
Yep, I agree. So I know we're almost like over time. So maybe next step, should we start a proposal? Like maybe like we can collaborate on a Google Doc, like or any other type of doc, and think of how we can actually integrate this with the train job controller directly, and think about short to long term priorities and what we how we can give this kind of short term value, and at the same time have a North Star vision, right? Like to bring this intelligence more to the resource optimization selection, right? So I think that definitely makes sense. Yeah, I think so actually. Like I think once we integrate optimization job with train job, we can definitely think on this as well, because that will be part of because optimization job will create a train job, which means like this also will work there as well during the hyperparameter optimization. All right, so great discussion. Anything else we want to talk about quickly here? All right, so let's definitely follow up for this. I hope like, maybe we can, think about this like, offline and, collaborate on the doc. And at the same time, let's, continue discussion for the release for 2.2. So definitely exciting, looking forward for this. All right, thanks everyone. Speak to you soon.